down to the fourth way. This is in two parts. First of all, comparing the size of political areas with this ArcGIS 3D web mapping application. Here's my short lesson based on that. It's right here, comparing the size of countries with this 3D web mapping application. I've got some questions in here that you could pose to students and also the tool itself. And you can use my questions, or you can just use the tool itself without my questions. If you don't like my questions, that's fine with me. But I really want people to use this tool because it's just fascinating. So here's the tool itself. It is a 3D scene based on the ArcGIS platform. And I can do things like, oh, you know what? We've been talking about map projections. And if we drag Greenland, for example, and we click on Greenland and we drag it down to Brazil, we can see the effect of, if we're looking at a 2D map in a map projection. So let's go ahead and do that. Comparing Greenland, and we're going to drag Greenland now down to Brazil. Okay, so I can see right away that Greenland is a lot smaller than Brazil. I can even fit Greenland inside Brazil. Whereas on the Mercator and other map projections, right, Greenland is huge compared to Brazil. So teaching about projections with scale as the framework, I think it's fascinating to be able to do that. So for example, here's another thing that we can do, right? We can say, oh, well, what about this? Well, let's go ahead and drop how about the Ukraine? It's a pretty big country, but a lot of students don't know that. If we drop the Ukraine onto another area of the world, we're going to drop it on Western Europe. Look, it's pretty big. It's wider than France. What if we drop it over here, Spain and Portugal? Okay, it's wider east-west than Spain and Portugal. What about compared to Algeria and so on? Okay, Algeria is a lot larger. The point is, this is a 3D tool. You can rotate these countries as well. But I think it's fascinating to be able to do this. Hey, let's say I'm from Texas and I'm studying Egypt. I have no idea how big Egypt is. So let's go ahead and select Egypt and let's drag it over to Texas. How big is Egypt compared to Texas? Sure, we can look at the area and so on and so forth. But if we want students to understand this at all levels of their education, sometimes a visual, right? That's the whole power of mapping. Sometimes a visual is the best way to do that. So now I can see that, you know what? Egypt is actually fairly comparable in size to Texas. It's a little bit larger than Texas, and we could go to the actual area and dimensions and perimeter and see how much larger it is. But it's just interesting to be able to do this for multiple states and multiple countries. So that is another tool that I think is interesting. You can always refresh this to get rid of the previous countries that you've selected. But I think it's just really interesting to be able to, and important, right? When students watch a newsreel or a news clip or read about a certain event happening, and for example, the horrible earthquakes in Turkey, how big is Turkey compared to other countries, for example, or compared to my own country or my own state within that country? So, okay, very good to be able to do this, and I encourage you to use this tool. Another one that's related, and let's go back to our lesson itself, which is actually a story map that I'm going to share in this video. This whole thing is a story map, so you have links to all these things. You don't need to be writing these down. But it's also a powerful but simple, easily implementable solution here to teach about scale, and that is exploring Mars with GIS, or Geographic Information System. So once again, I've got a short but hopefully helpful essay on questions that you could pose to students using this particular tool. This particular tool is a 3D Mars exploration tool that some of my wonderful colleagues created. So, okay, we've got Mars here. We've got different base maps that we can change it to. Oh, that's just fascinating to be able to do that. But we can do things like, okay, we're going to measure the size of the crater where the Perseverance lander landed back in 2021. So, okay, let's go ahead and measure that crater. Let's go ahead and do that. We'll start one end of the crater and go to the other end. Okay, 45 kilometers. Interesting. Okay, what if we wanted in miles? Okay, the 28 miles. Okay, fascinating. So we've got that. What about in my own county or city? How big is that compared to Denver or Shanghai? How big is that crater? It turns out it's fairly sizable, and it's nice and flat, which is one of the reasons why it was landed there. Fascinating to be able to look at these. Oh, look at this. This is what I love about mapping tools. I always notice things I'd never noticed before. Look, you've got these capabilities. Look at this fissure running through the crust of Mars here, just to the west of where the Perseverance. Oh, look at this feature over here. Anyway, you know what I mean. You're starting to look at things across space, and you're asking the whys of where. Just to the east of that lander is one of the great planes in Mars. Fascinating to be able to do that. But we need to move on. Another thing that we can do is we can say, oh, well, I'm going to go over here. I'm going to put north at the top here, and then I'm going to pan over to the other side of the planet, and I'm going to get rid of the measure tools at the moment. So I'm going to look at another side of the planet. Oh, look at this. This is just absolutely wonderful. Okay, we've got Olympus Mons here. Let's go ahead and measure Olympus Mons. So, okay, line, and we're going to measure across there. That's a pretty big volcano. In fact, that's the biggest volcano in the solar system that we know of so far. So, okay, 500 kilometers across, at least. It depends on where you measure from. But let's go ahead and do this. Let's go ahead and measure the elevation here. Ooh, okay, so we can measure this, and we're going to go right off the edge of Olympus Mons. Look at that. That is fascinating. You've got over 20,000 meters high, and going down to the basically a sea level. If there's zero elevation on Mars, there's no oceans, of course. But wow, that's a lot. How big is that compared to Mount Everest? Well, that's another thing we can do here is we can look at 3D models, and we can say, gosh, Everest, okay, let's take a look at that. You've got Mount Everest now, and you've got it on top of Olympus Mons. Now, sure, we're not looking at the entire Himalayas, but still, looking at Mount Everest and surrounding areas compared to Olympus Mons, it's tiny compared to Olympus Mons. So again, teaching about scale. What else can we do? We can say, oh, well, I'm going to compare 3D models, and I'm going to go down to the Grand Canyon. And then I'm going to scroll out so that I'm looking at another part of the surface of Mars, which I think is even more fascinating if possible. Let's go ahead and keep north at the top here. More fascinating than even the, oh my goodness gracious, look at this. This is absolutely amazing, right, folks? So let's go ahead and pan to a different part of Mars, the Valles Marineris. Okay, so there's these almost east-west valleys in here, and I'm going to have to go ahead and compare that again. Let's go ahead and grab the 3D model of the Grand Canyon. Okay, let's put it on top of the Valles Marineris, and let's rotate this. Let's grab these rotate tools. Let's rotate this so we're looking at the Valles Marineris, which is an amazingly deep and wide and long canyon, set of canyons on Mars all across the surface. Look at that. Look at the size of the Valles Marineris compared to the Grand Canyon. I mean, the Grand Canyon's big, but when you look at it compared to the Valles Marineris, oh my goodness gracious. It is, again, thinking about scale, it is tiny, both in width, but also in depth compared to the Valles Marineris. Oh my goodness, this is just an amazing tool, and lots more in, again, that lesson that I have created right here, where you're doing a lot of measurement and comparisons and looking at latitude, longitudes, and other things in that blog essay of mine. So I hope this has been helpful. It is basically 4 ways of teaching about scale using web mapping tools. They're all based on the ArcGIS platform from Esri. So again, powerful, easy to use. And notice also, I have not signed into anything. I'm just using a web browser. Think about that. That is amazing. So any student at any level can use a tablet, a laptop, probably not a phone, because you really do need a little bit of real estate here. But whatever device they've got, as long as they've got a halfway decent internet connection, you've got a lot of power at your fingertips. And I hope these 4 ways to teach about scale inspire you. Remember, I do have a playlist of 12 videos on this topic called Scale Matters that is a good supplement, I believe, to this. But I'd love to hear your feedback and how you use these tools in your own instruction. Thanks for being with me.